Last time, while trying to figure out how many apples I could gather from my orchard in a day, I came up with the idea of rates, a combination of two numbers, describing, in this case, a number of apples that I can gather in a particular amount of time. I ran into some problems trying to use rates. For one thing, while it's easy to think about rates that are one apple in some number of minutes, things get a lot more complicated when thinking about multiple apples in some number of minutes. And another thing, while I'd thought at first that if I had, say, 3 apples in 3 minutes, that would be the same as 1 apple in 1 minute, there are actually a lot of situations where that isn't the case. At least if I want to use rates in the way that I'm trying to use them. Today, I want to get a better handle on how rates work, and how I can use them for what I'm trying to do. The best place to start is probably by properly defining them. It's been a little while since I've had to get into the weeds of defining and proving things, but it feels like I'm at the point where it's going to be necessary. I want to say that a rate is a combination of two numbers, one describing, in this case, an amount of apples, and one describing an amount of time. I want it to be true that, for a particular rate to describe how quickly I can gather apples, it should be the case that I can find the amount of apples I can gather in any amount of time by dividing that amount by the amount of time in the rate, and then multiplying by the number of apples in the rate. And finally, I want to be able to say that a rate is bigger or smaller than some other rate, similar to how a number can be bigger or smaller than another number. A bigger rate should usually result in me getting more apples than a smaller rate. As for the first part, I think that just kind of has to be part of the definition, or maybe part of how I apply the definition to model things in reality. But writing this out has given me an idea for how to deal with the next part. If I have two different rates, say 5 apples in 12 minutes and 4 apples in 9 minutes, how would I go about comparing them? The amounts of apples are different, and the amounts of time are also different, so I can't use any simple heuristic tricks. But if I think in terms of which rate gives me more apples in the same amount of time, then I can still solve this. Now, I can't just pick any old time to compare the rates at. If I picked 5 minutes, for example, I'd not be able to gather any apples in either case. If I picked 9, I'd be able to gather 4 apples in this case, but wouldn't be able to gather any in the first. And if I picked, say, 14, well, then I'd be able to get 5 in the first case, but still just 4 in this one. I need the amount of time that I pick to be large compared to the amount of time used in both of the rates. And I think it would be nice if it divided by both of them without leaving any remainder. Thanks to what I know about division and multiplication, I actually have exactly the number to use for this. If I multiply 12 by 9, I get 108, and I know that 108 divided by 12 is 9, and vice versa. So, if I were to try and find out how many apples I could gather at each rate in 108 minutes, I would end up with finding that I gathered 9 times 5 apples in the first case, or 45, and 4 times 12 for the other, or 48. If rates work the way that I want them to, this should tell me that gathering apples at the rate of 4 apples in 9 minutes should usually give me more apples than gathering at the rate of 5 apples in 12 minutes would. There's still a bit of messiness when dealing with relatively short amounts of time. As I noted before, if I only had 14 minutes to gather apples, then I'd end up gathering more at what I've determined should be the slower rate. I wonder if I can figure out the limits on when this can happen. Is there some amount of time which, as long as I spend at least that long gathering apples, the faster rate will always give me more apples than the slower rate? I could keep playing around with these example situations and trying to figure things out that way, but I think it's time to move away from specific numbers and examples and start thinking about things more abstractly. What exactly are rates on the mathematical level? I've been thinking just in terms of apples and time, but there's no reason I couldn't use other things as part of rates. I could use the same language to talk about apples in boxes, for example, and say something like, I'm storing apples in boxes at a rate of 12 apples in 3 boxes. In the same way that I've been saying that a rate of 12 apples in 3 minutes means that I would gather 24 apples in 6 minutes, I could say that a rate of 12 apples in 3 boxes means I would have 24 apples in 6 boxes. At the core of it, I think that I should say that what a rate is a way to describe how something is being grouped up. When I'm talking about boxes, it's grouping apples up in sets of boxes. And when I'm talking about gathering apples, it's grouping apples up by the amount of time it takes to gather them. I'll define a rate as a combination of two numbers, one of which I'll call the payload, describing an amount of something. The other I'll call the base, describing how those things are grouped together. I'll say that when reading out a rate, I can say that it's the payload per the base. So if I'm talking about an amount of apples in an amount of time, for example, I'd talk about some number of apples per some number of minutes. And finally, to keep up with everything else I'm doing, I'll say that I can write out a rate using numerals like this. Now that I've got this all formalized, let's think about how it works with the original problem I came up with rates to solve, gathering some number of apples in a certain amount of time. If I gather apples at a rate of A apples per B minutes, I'm saying that in a period of B minutes, I will gather A apples. I'm not saying anything about how those apples get gathered. Maybe they're spread evenly throughout the B minutes. Maybe I gather all of them right at the end. The point is that I have to spend the full B minutes before I get a full A apples out. So then, if I have some larger amount of time, C minutes, I can find out how many apples I can gather during it by splitting it into chunks of time that are B minutes long, and then multiplying the number of chunks I get by A. This all works exactly like before. I'm not treading any new ground here, but I feel like I've got a firmer understanding of the difference between the mathematical model I'm using and the system that I'm modeling with it. I feel less like I'm making it up as I go along, and more like I have a grounded reason for why I'm doing what I'm doing. That's one of the two things I wanted to be able to do with rates settled. So how about the other? Based on my earlier thoughts about comparing rates, I'm pretty sure I want it to be the case that one rate is more than another if the product of its payload and the other's base is more than the product of its base and the other's payload, and vice versa. I already know that a rate being more than another in this sense doesn't necessarily mean that it would always give a higher result, but I don't think that's necessarily a problem on its own. Is there ever a case where there are two rates, each of which thinks that it's more than the other? For that to be the case, let's say that there are two rates, A per B and C per D. And let's say that A per B is more than C per D, in the sense that I've defined. So A times D is more than C times B. Well, now that I've written it out, I can see clearly that for C per D to also be more than A per B, C times B would have to be more than A times D. But I know that if a number is more than another number, it can't also be less than it, so this can't happen. Just like numbers, one rate cannot be both more than and less than another rate. That said, I am realizing now that there's an important way in which rates are different. For any two different numbers, one is always more than the other. But there can be two different rates, neither of which is more or less than the other. 1 per 2 and 2 per 4, for example, have the products of their respective payloads and opposite bases both being 4. In addition to being more than or less than, two different rates can also be equal. I don't think this is really a problem. I can also talk about two numbers being equal in the sense that 2 plus 2 is equal to 4, or in a more general sense that the sum of A and B is equal to the sum of B and A. As for other ways that this might go wrong, if I know that A per B is more than C per D, and that C per D is more than some other rate, E per F, is it possible for A per B not to be more than E per F? I know that A times D is more than C times B, and that C times F is more than D times E. So what can I figure out about A times F and B times E? I do have an idea, but it's going to require some facts about multiplication that I haven't properly proven yet. I don't want to do it right now, but I'll add a proper proof of these things to my notes when I have the time. Since A times D is more than C times B, I can say that A times D times F is more than C times B times F, and that these numbers are equal to A times F times D and C times F times B, respectively. I know that the latter is more than D times E times B, which is equal to B times E times D. Putting this all together, I know that A times F times D is more than B times E times D. So I can say that A times F is in fact more than B times E. Everything seems to be working like I want it to. I can't think of any other way that this definition for one rate being more than another could break down. Putting that aside for now, let's get back to my earlier question of under what circumstances using a larger rate can give me a smaller end result. Just to keep things easy to talk about, I'll keep thinking in terms of time and apples. There are 7 different numbers involved here. The 4 that make up the individual rates, 1 describing the time that I spend gathering apples, and for each rate, 1 describing how many apples I end up with. In terms of the math involved, I'm asking what has to be true for this number to be smaller than this number. I think I might be able to get to a partial answer. This number is t divided by b times a, and this one is t divided by d times c. Let's say that t divided by b and t divided by d both have remainder of 0. Then what would happen if I multiplied them both by b times d? T divided by b times a times b times d should be equal to t divided by b times a times d, which is just t times a times d, and should in turn be equal to a times d times t. Likewise, this number times b times d should end up being equal to b times d times t. I know that a times d is more than b times d, So as long as t has a remainder of 0 when divided by b and by d, the larger rate actually will always give the larger end result. If the remainder of t divided by b isn't 0, though, this gets a lot messier. I think I can see how I would go about finding whether this can be bigger or smaller, depending on what the remainders of t divided by b and d are, but I'm not at all sure that I can make it into a clean and simple pattern. Certainly not in the amount of time I have left for today. That said, even as much progress as I've made is more than enough for now. Being able to say that I have this idea of rates, and understanding what it means for rates to be more or less than one another, I feel like thinking about them has opened my mind to a lot of new ideas that I hope to explore down the line.